All right, so let's go ahead and read a configuration for something like tungsten. Okay, so tungsten is element number 74, and let's see. It is right here, W. That's the symbol for tungsten. All right, so what we learned about electron configurations was that you could start with an Aufbau diagram and draw your arrows and then read it off the picture, or we could bypass drawing the picture altogether and go straight to the periodic table, so long as you knew that this side was called the S block, plus that block over there. This was the P, this was the D, and this was the F. And that you could simply read it like we read a paragraph in English, where you go read it left to right, line after line after line, until you get to the element that you were looking to describe. But, you know, the problem with this is that we're doing tungsten, and we're doing something that's really deep in the periodic table. And, well, it's going to take a lot of paper for us to do this. So the first thing that I want to accomplish with you today is to show you how to actually read it, because reading it, especially something deep in the periodic table, is kind of funky. And then the second thing that I want to teach you today is how to do this shorter, right? Because we really don't want to take up half a sheet of paper to do this. And after a while, reading configurations gets kind of repetitive anyways. So let's start with just how to basically do it. All right, so when you read an electron configuration, you really should be doing this in order of increasing atomic numbers. So you guys have your periodic tables where you remember I made you draw this the other day with pictures of the S's and the P's and the D's on top, and you colored it in? So take those notes out and add this to this. So when you read a configuration, number one, you read left to right, from top to bottom, and number two, and I'm going to put a star on this, I might highlight it in a minute because this is really important. You read in atomic number order. So you read these things sequentially by atomic number. All right? Well, here's where things get kind of ugly. Take a look at your periodic tables. Especially when you get down to the 6th row. I'm going to grab one. Okay, so what do you notice about the atomic number order when you get down here to the 6th row? We have element 55, 56, 57, and then what comes after 57? 72. Well, this isn't going to work. Where's 58? 58's down here. Okay? So when we read tungsten, we're going to have to read these three, then come down and read 58 to 71, and then once we're done with 71, we come back up to 72 and then read all the way over to 74. Okay? All right, so let me just transfer these numbers here. So this again was 55, 56, 57, bless you, 72, 73, 74, and then down here it's 58 over there, 71 over there. Okay, so let's do tungsten. We start in the upper left-hand corner, right? We'll do our example here on these notes. Tungsten. Number 74. All right, so if we're up here, where am I? See where my finger's wiggling? What is that? Start in the upper left-hand corner. What's that box that we're labeling? 1s, and how many go in that orbital? 2. 1s, 1, 2 boxes. So we're done with the first row. Let's go to the second row. Where am I now? 2s. How many electrons go in that 2s orbital? 1, 2. And then come over here. Where am I? 2p. How many electrons go in those 3 orbitals? 1, 2, 3, 4, 5, 6. All right, come here to the third row. Where am I now? 3s, how many fit there? 2, and then come over here. Where am I? 3p, how many fit there? 6, and then I come over here. Where am I? 4s, how many fit there? And then come over here. Where am I? 3d, how many fit there? 10. And then come over here. Where am I? 4p, how many fit there? And then come over here. Where am I? 5s, how many fit there? 2. And then over here? 4d, 10. And then 5p, 6. And then, let me lift this so you can see. Over here, 6s, 2. So that's element number 55 and 56. Now we'll read 57, right? So what is that? 5d1. All right, and then what's next? Well, do I go to the right? No, where do I go? I shift down here, all right? And so what is that down there? 4f, and how many are there in that row? There's 14 of them, okay? And that takes me to element 71. Now element 72. We're at 5d, and we would have to go 1, 2, 3 boxes to get to tungsten, all right? We're not done, though. Yeah. I was doing elements 58 to 71 so I could come back to 72. Okay? Give me a second, Caleb. Now, if you look at the configuration, it's right there. If you were sitting in your algebra class, what would you say about those two things? They're like terms, so you can combine them. So what you would do is cross this out and make this a 5d4. Okay? You would combine those like terms. What's your question, Kayla? Was that it? Yeah. Okay. And you put them afterwards, not before. Okay?
So wait, it goes after the 4F?
Yeah. Because on the Aufbau diagram, the D is higher than the 4F, because it takes more energy to be in the D than the 4F. When you're writing these things off the periodic table, the order has to do with how much energy it takes to be there, not necessarily distance from the nucleus. Okay? All right, so I'll practice another one. Something ugly. Yeah, Morgan's saying no, but I'm saying yeah. I'm feeling it. Something real ugly. Because I'm not going to let your battleship partner take it easy on you. Dysprosium? What number is that, Brianna? 110. Oh, you are mean girl. Oh no, that's not dysprosium. That dysprosium is dy. DS is even better. Darmstadtium. That's what that's called. All right. Yeah, we can do DS. Okay. Oh, Brianna, this is ugly, ugly, ugly. DS. We got to find it here. Not yet. You need to suffer a little bit more. He really wants to do the noble gas thing. Here's DS. All right, so take a minute. See if you can figure out how to do it. Again, I think it's helpful to look at your colored table and then a real table so that you can see the atomic numbers of stuff. DS, right there. It's not on your periodic table? Because the periodic table that was generated by the Florida Department of Education was, this is the periodic table that they used to give on the old Science FCAT. This is at least 15 years old. So guess what? It's outdated. Okay. Sure. How about the next door neighbor, Meitnerium? 109. At least it's on your table. How about that? Is it easier? Okay, you guys ready? You're not. All right. What? I'm waiting. All right, ready? Okay, so where do we start? 1s2. All right, and then where do we go? 2s2, and then 2p6, and then 3s2, and then 3p6, and then 4s2, and then 3d10, and then 4p6, and then 5s2, and then 4d10, and then 5p6, and after that 6s2, after that 4f14, and then 5d10, and then 6p6, and then 7s2. All right, now that's where things get funky, right? So after 7s2, where do I go? I'm gonna do. You're gonna do 5f14 next. Okay, I'm okay with that. And then you're gonna come back and do 6d7. What? What's wrong, Victor? Mm-hmm. Right. So, like, if you're doing that in sequential order, you would read actinium, right, which would be 6d1, and then after 89 comes number 90, all the way through 93. That would be 5f14, and then you have to come back and keep reading the 6ds to get to meitnerium. So, yeah. So, but then when you're done, these are like terms. So you have to combine them. And so then you could get rid of that and change that to a 7. It's extra work, but I'd rather you do it this way, just to make sure that you account for every electron in that particular atom. If you get in the habit of shifting down and then coming back, you might miss one. And the other problem is that not all periodic tables put lanthanum and actinium here. Some periodic tables put them down here. And then you really get in trouble, because then you'll be like one off from your count. So I'd rather just you go by atomic number order and then combine like terms on the back side. It takes a second longer, but you'll get it right every time. Okay? So that was our ridiculous configuration. Right? Long. I heard that little noise. What was that? I heard that noise out of you. Didn't you make a little noise like who's long? I heard a noise. By the way, total waste of time. Total waste of time. because as Victor has been telling us since 7:20, right? There's a shorter way of doing this, okay? So I'm going to show you how to do that really quickly, and then we'll practice a few, okay? Your homework tonight out of the book is some of the same questions that you did last night for homework. So if you notice, it says page 152, the first two questions, 40, 41, you did last night for homework, right? The difference is, this time, I want them in noble gas. I want them in noble gas form, okay? So you're not writing them the long way, you're going to write them the short way, okay? All right, so let's go back to our notes. Let's go back to our notes. So, if you are reading elements with high atomic numbers, the configurations can get long. And it would be really easy if you're writing a really long configuration to mess up, right? Okay, so in order to avoid that and to really focus on the important part of the atom, which is the outermost layer, not the inner ones, we have a shorter way of doing configurations, and you can do it with something called noble gas notation. So noble gas notation exists as a shorthand, right? So as a shorter way to write the same relative information, okay? Okay, so the way noble gas notation works is you find the noble gas that comes immediately before the element that you want to read. So you find the noble gas that comes before the element of interest, okay? For you to be able to do that, you have to know the names of the families, right? Okay, so where are the noble gases on the periodic table? Is where? It's this last column. These are the noble gases. All right, so if we were reading tungsten, what would the noble gas be that comes right before it? What would it be? Xe. So the simplest way to do it is just go up a row all the way over. Okay? What you do with the noble gas configuration is you write the symbol for Xe in square brackets, and then you just start reading from there. All right? You write that in square brackets, and then you just start your reading from that point. Okay? So you find the noble gas that comes before the element of interest. Okay? Write it in brackets. Start reading from that noble gas, like you were before. Okay, so we're going to do an example. Maybe not tungsten, because tungsten's long and ugly. Because you have to do that shift from the S to the F to the D. Francium, I love francium. Of course I can. It's my favorite element. Huh? Yeah, we can do francium. Francium is element number 87. Sure can, buddy. All right, so let's find it. It's right there. Right there where my finger is. So what's the noble gas that comes right before it? You go up a row, all the way over. It's Rn. You write that in square brackets. And then you start reading from there. Where am I? 7s1. So it's just Rn bracket 7s1. Right? Better than starting from the beginning, right? Okay, let's do another one. Got a bunch of them on the board. No, I'm going to decide which ones. Okay? How about sulfur? Let's do sulfur. So sulfur is right there. What would that be? Well, go up a row all the way over. You got to do the noble gas that comes before it, not the one that comes after it. Okay? And by before, the way you determine if you're looking at before or after is you look at the atomic numbers. So what's the atomic number for sulfur? It's 16. What is it for argon? It's 18. Does the number 18 come after or before 16? It comes after. You don't want after. You want before. All right. So listen. Shh, be nice. Okay. So what's the noble gas that comes right before sulfur? Neon. So you write that in square brackets, and I'll show that on the screen in a second. And then you start reading from neon. What will come next? 3s2, and then read over 3p 1 2 3 4. 3p4. Okay, so it looks like this down here. Okay, so neon 3s2 3p4. Isn't that better? Was Victor right? I should give him a pat on the back on the way out. Alright, so what I'm going to do is I'm going to pause the recording, and what I want you to do is on your paper, try the 5 that are up on the board. So I want you to try lithium in noble gas form, HS, I don't even know what that is. HS, what does that stand for? Potassium. And then francium we did already, hydrogen, and then rhodium. See what you can do with those.